And we're back here with some sine law. Now, this video, again, suitable for a 3C class, grade 11 students. Prerequisite skills we're going to rely on. Again, we're relying on our ability to work down. At this point, nearly every lesson in the course has relied on our ability to work down. So if you're struggling with working down, I encourage you, go find that video, go practice those skills, because that can get in your way time and time again. So I'm hoping you've been able to recognize the value in working down as we go through these lessons. We're relying on your ability to calculate a trigonometric ratio. That means you need to be able to handle something like the sine of 38 degrees. You need to be able to throw that into your calculator and come up with a decimal value. We also need to rely on our ability here to calculate an angle from a trigonometric ratio. That means if we have the sine of theta equals 0.7642, we need to be able to turn this into an angle by taking the inverse sine of both sides. Right? Now, this is not new to you in this course. This is not new to you in math. You learned that in grade 10. Now, we'll jump right into it. The first thing that stands out right here is we do not have an angle here that, although we might have an angle that looks like it's 90 degrees, it's not labeled 90 degrees. We can tell, because if we add both of these up, they do not add to 90 degrees, that this angle, this interior angle here, is not a 90-degree angle. That means this is not a right triangle. If it's not a right triangle, that means we're not able to use our SOHCAHTOA that we have been relying on thus far. Now, if we're not able to use our SOHCAHTOA, we still need to be able to label our triangle. So when we used SOHCAHTOA, we labeled our triangle from a hypotenuse, an adjacent side, and an opposite side. Well, in this case, because we have no right angle, we're not able to have a hypotenuse of this triangle. The hypotenuse we're used to always finding as opposite to the right angle. Well, if this has no right angle, this has no hypotenuse. I'll say that again. When we're working with a triangle that's not a right triangle, we do not have a hypotenuse to work with. So instead, we still do want to keep track of our angles and our sides. We still will want to represent them algebraically, but we cannot use hypotenuse, opposite, and adjacent. In this case, we're going to pair off our angles with opposite side lengths. So here, I have an angle and an opposite side length. We will call the angle, angle A. We'll call the side length angle lowercase a. All right, we see another angle over here. We'll call that B. Opposite to this second angle, we have another side length. We'll call that lowercase b. If we wanted to at this point, we could call our remaining side length and angle lowercase c, but at this point, we don't have C angle or C side length to work with right here. We're purely working with two opposites. We're working with 57 degrees, which is opposite to 12 feet, and we're working with 38 degrees, that is opposite to our unknown angle x. Now, our sine law tells us that the sine of one of these angles, we'll say the sine of angle A, divided by the side length of A is going to be equal to the sine of angle B divided by the side length of B. If you're watching this video, this is review, right? You learned this in grade 10 already. You can explore and discover your sine law in another way. We're not going to do that here. I'm just throwing it right at you. If this sine law is true, then the reciprocal would also be true. And that is, we know that A over the sine of A will be equal to B over the sine of B. Now, either of these forms will be suitable for us depending on the unknown that we're trying to find. If you accidentally use the wrong form, that's fine. There's just one extra step in the algebra. That being said, if you're working your way through and you feel a little bit stumped with the algebra, maybe you've used the version that's not most suitable for the problem at hand. So we'll work right here. You'll notice our first example, we've already marked up a whole bunch of it. That's okay. We're going to leave it right there because when we're working with our sine law, we will need to label our triangles with A's and B's. Now we'll start off, we're going to work down. In this case, our unknown that we're trying to find is a side length. If the unknown is a side length, then the version of the sine law that we'll want to look forward to is the version that has a side length in a numerator, because as we learned when we worked with our SOHCAHTOA, it's a little bit more straightforward to isolate for an unknown if it's already in a numerator. So we'll jump in with this right here, and we will substitute our values in here that we know of already. So the values that we know of already, I'm just moving that over so we have more space. The values we know of already, we know side length A, we can call that x because that's what we're trying to find. We know the sine of 38 degrees will be on the same side because our 38 degrees is opposite to our side length x. And we know side length B is 12 feet divided by the sine of 57 degrees. Now, if you're ever unsure which goes in the sine ratio here, it's always 100% of the time going to be an angle that finds itself in a sine or a cosine or a tangent for that matter ratio. All right. Now, all we're doing is calculating. So this right-hand side we can calculate right away, but if you're feeling a little bit more comfortable with the algebra, you can recognize, hey, this is the x that we're looking to isolate. It's not on its own yet, so we will need to deal with this sine of 38 degrees. Right now, x is being divided by the sine of 38 degrees, so we'll need to perform the opposite operation right here and multiply both sides by the sine of 38 degrees. Nice and easy. This is not new. We've handled this before. Now, if that's the case, on the left-hand side, our sine of 38 degrees cancel out, leaving us just with an x on the left-hand side. The right side, we can throw this all into our calculator together right here. 12 times the sine of 38 degrees divided by the sine of 57 degrees. If you forget in which order to handle these, that's okay. You can handle this as 12 divided by the sine of 57 degrees, then times the sine of 38 degrees. This is multiplication and division. The BEDMAS does not matter right here. So we'll throw this right into our calculator. In order to handle this, I'll handle it in a few steps because some of you will be doing the same thing yourself. Now, we're working with the sine of 57 degrees. I'll evaluate each and every piece of this. If you're comfortable throwing it all into your calculator at once, that's fine. Oops. Sine of 57 degrees, we're working with 0.8387. We'll round that. And the sine of 38 degrees, we're handling this right here with 0.6157. 0.6157. Good, and then I'm throwing this into my calculator. Again, if you're comfortable doing this all in one step, do this all in one step. This is 12 times 0.6157 divided by 0.8387, and I'm working with 8.81. Now we'll ask ourselves, does this final answer for a side length x, does this make sense? Well, we already know, if you recall from our SOHCAHTOA lessons, we know from working with SOHCAHTOA that the longest side lengths will be opposite the largest angles. And that is, the larger the angle, the larger the side length, the smaller the angle, the smaller the side length. So, if I notice here, 38 degrees, that's a little bit smaller than 57 degrees. So I'm expecting a side length that's smaller than 12 feet. Is that we have? Absolutely. That's a reasonable side length. Nice work. We're working with 8.81. In this case, our units would be feet. That's all well and good. We've handled our sine law now. I encourage you, pause the video here, try to set up this triangle for sine law. Again, this is labeled with an unknown angle theta, so this time we're looking for an angle, not a side length. But we can assume this is not a right triangle because it does not say that this is a perfect right triangle. So pause the video here, try and label your triangle. Good, now math convention does tell us that our angles will be capitals. It's not overly important other than to make sure that your angles will remain within your sign of your formula. So our sine law that we're using here, I want you to, you know what, if you're feeling super comfortable right here, I encourage you pause the video and do what we just did before. Do it again, try out your sine law on your own, and then unpause and see how we do it. Because right here, we're handling this time the version of the sine law we'll be using will be our version that has sine in the numerator, because what we're finding this time is an angle. So we're working with the sine of A over A is equal to the sine of B, over B. Fantastic. Then we're substituting in our values. Instead of using a capital A, we're using an angle theta because that's our unknown. Divided by, I'm just going to move this A over so we don't confuse it for being in our equation, divided by side length A, that's 15. The sine of B, well, B is 36 degrees, and side length B is 9 units in length. What are those units? We're not sure, so we will leave them unlabeled. Then we're performing some algebra. So we recognize that we will need to isolate for the sine of theta. In order to do that, I need to perform the opposite of dividing 15. I'll multiply both sides by 15. Those will cancel out. I'm working with the sine of theta is equal to the sine of 36 degrees divided by 9 times 15. Great. Now, if you want to handle this all in one step, you can. You can take the inverse sine of both sides and then perform all of that in one step with your calculator. I'm not quite going to do all of that in one step right here. I'm going to evaluate the sine of 36 degrees, then I'll perform my multiplication and division, and then I'll see what I get. So the sine of 36 degrees. In this case, I'm working with 36. I'll take the sine of that, thank you very much, and then I will multiply that by 15. And then I will divide that by 9. So I am working with right here something along the lines of 0.9796. 0.97, and if I remember correctly from my SOHCAHTOA, I should leave a little bit of space here. 9796. Fantastic. What's equal to that? Oh, the sine of theta. I'm looking to get theta on its own. I take the inverse sine over here. If I do that to the left, I have to do it to the right. My inverse sine and sines cancel out. I'm left with theta is equal to the inverse sine of 0.9796. 0.9796. And I'm taking the inverse sine 78.4 degrees. I can round that to 78 degrees. Again, we can check. Does this answer make sense? My largest angle should be opposite my largest side length. 15 units is greater than 9 units, so I'm expecting my largest angle to be opposite. That's the angle we were finding. 78 degrees is, in fact, greater than 36 degrees. That answer makes sense to us. Good. Now lastly here, let's just take a look at what is required in order to use our sine law, and it's those two pairs, right? One pair, an opposite angle and side length, and another pair, an opposite angle and side length. In order to use our sine law, we need those two opposite pairs because that is what fills up our equation here. Only one of those can have an unknown if we're going to isolate for it. We'll double check our second triangle here. Do we have two opposite pairs? Absolutely. I see one opposite pair right here. I see another opposite pair right here. Two side lengths, two angles, opposite one another. That's what it takes. If you followed along, I'm hoping you're feeling a little bit more comfortable with this review of your sine law. Nice work.